Welcome back to Math 103. This is the first video on measuring power, which is the second topic in the course. Thus far, we have focused on the candidates in an election rather than on the voters. So in the situations that we've been discussing, the voters were all on equal footing, in the sense that each voter would cast one preference ballot. Now we're going to consider situations in which some voters cast more votes than others. What? Isn't that outrageous that some voters are casting more ballots than others? Well, actually, there are many good examples in real life in which it makes sense that some voters are able to cast more votes or in some way have more power than other voters. Here are some examples. The United States Electoral College, which is officially where the president is actually elected rather than in the polling booth. Now, it is true that in the polling booth, each voter casts one vote for president, but that's not the end of the story. Then the Electoral College convenes, and each state casts a certain number of electoral votes based on population, but not exactly proportional to the state population. So California casts 55 electoral votes, and since California, like most states, has a winner-take-all system within the state, whoever wins California in the presidential race gets all 55 of California's electoral votes in a single block. Similarly, New Jersey votes as a block and gives all 14 of its electoral votes to whichever candidate for the presidency won New Jersey. Delaware casts a block of 3 votes in the Electoral College. Right, so it makes a certain amount of sense that California, which is much more populous than New Jersey, would have a greater weight when it votes as a block than New Jersey does, and New Jersey should have a greater weight than Delaware. So this is actually not so outrageous that the states, when the states are the players and not the individual voters, it makes sense that each state has a different weight, and in that sense casts a different number of votes than other states. Another example is a corporate shareholders meeting in which each share counts as one vote, but different shareholders own different number of shares. So someone who owns 1,000,000 shares should cast more votes than someone who owns 1,000 shares. That actually does make sense. Another example is the UN Security Council, and this is more subtle. This is an example in which each member casts one vote, but the vote of a permanent member, that is, any of the United States, the United Kingdom, Russia, China, and France, a vote of a permanent member counts more heavily than the vote of a non-permanent member. So there are 5 permanent members and 10 non-permanent members. The non-permanent members rotate, even though each one officially casts one vote, and in that sense they are all equal. It turns out that some council members are more equal than others. Okay, so what does it mean that the votes of the permanent members count more heavily? Well, it means that a no vote by any one of the 5 permanent members vetoes the proposed resolution. So if all 14 members of the council vote yes for something, but just one of the permanent members votes no, then nothing happens. Okay, the resolution is defeated. Another example is a university committee, on which the university president casts 5 votes, the dean casts 3 votes, a faculty member casts 2 votes, and the student representative casts 1 vote. So it might outrage the student representative to have fewer votes than the university president, but within the institution, there is a certain rationale behind setting things up in this unequal way. Our recurring question is the following. In each of these examples, what share of the actual power does each voter really have? That turns out to be a hard question. This is much more subtle than it looks, and this is where we need some mathematics to help us sort it out. Here's an example that will help us understand why this question is not so easy and not so straightforward. A 3-member commission is formed to advise the governor of New Jersey on various matters. There is one representative from northern New Jersey, another from central New Jersey, and another from southern New Jersey. Suppose that the boundaries between these regions are drawn precisely so that 4/9 of the state population lives in northern New Jersey, 3/9 in central New Jersey, and 2/9 in southern New Jersey. And if you sit down with a list of county populations, there is a way of drawing this so that it plausibly breaks down into 3 regions that are recognizably northern, central, and southern. I've not drawn it very precisely here, but this is just to give an idea. And it will turn out, if you draw it the right way, that these really are the fractions of the total population living inside each region. And to make it even a little bit more concrete, there are approximately 9 million people living in New Jersey. 5 million of them were riding on Route 18 this morning, and 4/9 of that would be 4 million people. So 4 million people living in northern Jersey, 3 million in central, and 2 million in southern. Right? So that's a concrete way of thinking about it. Since these regions have different population sizes, we can ask, should each representative have the same influence on the committee? Or should northern New Jersey have more influence than central, and central more influence than southern? Well, one intuition about fairness, you might or might not agree with this, is that sure, northern should have more influence than central because it has a greater population, and central should have more influence than southern because it has a greater population. But more specifically, more precisely, each committee member's fraction of the real influence, whatever that exactly means, and we're going to come back and make this precise, but there's an intuition that says that each member's fraction of that real influence should be equal to his or her region's fraction of population. Okay? If you don't share this intuition, math alone is not going to change your mind, but this is a very common intuition. So more precisely, more specifically, according to this intuition about fairness, a region with 4/9 of the population should have 4/9 of the power. If you have 3/9 of the population, you should have 3/9 of the power, and if you have 2/9 of the population, you should have 2/9 of the power, 2/9 of the influence. What exactly 2/9 of the influence on the committee means we'll come back to, but this proportionality, your power, your influence should be proportional to your share of the population. That is a common intuition, and we want to explore that. So how exactly do we achieve this goal of making your power on the committee proportional to your share of population? Well, we can ask, should each representative have 1 vote on the committee? Or should the northern New Jersey rep have more votes than the central New Jersey representative, and the central New Jersey representative more votes than the southern New Jersey representative? And if so, exactly how many votes should each representative have? Well, we can see one thing right away, and that is that if you give each representative 1 vote, then for sure you're going to give each one of them equal power on the committee. And if we're trying to avoid that, if we're trying to give each representative power proportional to their share of population that they represent, then we're going to have some kind of a scheme like this. We're going to find some way of giving just the right number of votes to northern Jersey, just the right number of votes to central Jersey, and just the right number of votes to southern Jersey to make the distribution of power match the distribution of population. So before going on to the next video, I invite you to answer the next question. Exactly how can we give a different number of votes to each representative so that each representative's share of the power will be proportional to that region's share of the population?